The closest star to our Sun, Proxima Centauri, has a planet, Proxima b, just 4.2 light-years away. For years, it was only a faint signal, a wobble in starlight. Today, NASA has released the first direct images and data, turning Proxima b from theory into reality. This is a milestone. For the first time, we have a detailed portrait of an exoplanet within our galactic neighborhood. The new data reveals its size, hints at its atmosphere, and even suggests what its surface might be like. We're no longer asking, is there a planet? But what is this planet like? This achievement is the result of years of innovation, building telescopes sensitive enough to detect the faintest planetary heat trillions of miles away. It's a testament to human curiosity and our drive to understand our place in the universe. The information from Proxima b is more than numbers. It's a window into another world's potential. Today marks the beginning of a new chapter in our search for life beyond Earth. Proxima b's story began in 2016, not with a picture, but with a wobble in its star's light. Astronomers at the European Southern Observatory used the radial velocity method, detecting the star's subtle movements caused by an unseen planet. The HARPS spectrograph in Chile measured these shifts, revealing a repeating signal every 11.2 days, a planet tugging at its star. Proxima b is at least 1.17 times Earth's mass, orbiting just 4.24 light-years away, our closest exoplanet neighbor. Its size and location in the habitable zone immediately sparked questions. Is it a barren rock, a water world, or something else? The radial velocity method gave us its mass and orbit, but left its radius, atmosphere, and surface a mystery. Proxima b was a ghost in the data, a tantalizing hint, not a picture. Confirming its existence and learning more required new technology and direct imaging. The 2016 discovery was just the starting line, a race to truly see and understand our nearest planetary neighbor. Now, with today's data, we're finally crossing that finish line. The journey from a faint signal to a detailed world is a triumph of modern astronomy. Proxima b is no longer just a theory. It's a place we can begin to explore. The next steps, uncovering its secrets, one observation at a time. Our cosmic neighbor is now within reach. To understand Proxima b, we must first know its star, Proxima Centauri, a red dwarf. Red dwarfs are small, cool, and dim. Proxima Centauri has just 12.5% of the Sun's mass and a fraction of its brightness. Its faintness means it's invisible to the naked eye, despite being our closest stellar neighbor. Proxima b orbits just 7.5 million kilometers from its star, less than 5% of Earth's distance from the Sun. This close orbit means a year on Proxima b lasts only 11.2 Earth days, and the planet is likely tidally locked. One side in perpetual day, the other in endless night. Red dwarfs are notorious for violent flares. Proxima Centauri can unleash bursts of radiation far stronger than our Sun's. These flares could strip away a planet's atmosphere and bombard its surface with harmful radiation. Yet, red dwarfs live for trillions of years, offering a long window for life to potentially emerge. The Terminator line, the boundary between day and night, might offer temperate conditions, a possible refuge for liquid water. Understanding this dynamic, often hostile environment is key to interpreting Proxima b's potential for habitability. The star shapes everything about its planet temperature, atmosphere, and the very possibility of life. Proxima Centauri's extremes set the stage for the drama unfolding on Proxima b. The new data lets us finally see how this cosmic relationship plays out. Directly observing an exoplanet like Proxima b is a monumental challenge. The planet is faint, lost in the glare of its star, like spotting a firefly beside a searchlight from miles away. Ground-based telescopes struggle with this contrast, and Earth's atmosphere blurs the view. That's why initial discoveries relied on indirect methods, like radial velocity. Proxima b doesn't transit its star from our viewpoint, so we can't use the transit method. To see it directly, astronomers needed a coronagraph, an instrument that blocks starlight to reveal faint planets nearby. Building a coronagraph with the precision to suppress starlight by a billionfold was a feat of engineering. Even so, ground-based observations hit their limits. To truly see Proxima b, we had to go to space. This need drove the creation of a new generation of space telescopes. The James Webb Space Telescope, or JWST, is the game changer. Launched in 2021, JWST is the most powerful space observatory ever built, optimized for infrared, perfect for studying cool stars and their planets. Its massive 6.5-meter mirror collects faint light with unprecedented sensitivity, while a tennis court-sized sun shield keeps it ultra-cold. JWST orbits at the second Lagrange point, far from Earth's heat and light. For Proxima b, JWST's NIR cam and MIRI instruments, equipped with advanced coronagraphs, block out the star's glare to reveal the planet. The telescope's stability and precision allow it to separate Proxima b's faint glow from its star. Imaging Proxima b required hours of careful observation and sophisticated data processing to subtract residual starlight. Techniques like angular differential imaging helped isolate the planet's signal. The result, our first direct image and thermal map of Proxima b. This is the technological leap that made today's discovery possible. NASA's data gives us our first direct look at Proxima b's physical traits. Infrared observations reveal a dramatic temperature difference. A scorching day side, a frigid night side, evidence of tidal locking. Proxima b's radius is about 1.03 times Earth's, and its density confirms it's a rocky terrestrial planet, not a gas giant. The Terminator line, where day meets night, may have moderate temperatures, potentially the most habitable region. The sharp temperature contrast suggests a thin or absent atmosphere. Surface reflectivity hints at a barren, rocky landscape, similar to Mars or the Moon. There's no sign of global oceans, but localized pockets of subsurface water or ice remain possible. These first findings transform Proxima b from a theory into a tangible, if harsh, world. One key goal. Does Proxima b have an atmosphere? Using transmission spectroscopy, JWST searched for atmospheric gases by analyzing starlight filtered through the planet's edge. The result, a very weak absorption signal, indicating any atmosphere is extremely thin, likely stripped by stellar flares and wind. There are tentative hints of carbon dioxide, a heavy molecule that could linger even as lighter gases escape. A thin CO2 atmosphere might create a modest greenhouse effect, warming the Terminator zone enough for liquid water. No signs of oxygen or methane, key biosignatures, were detected, but the data isn't definitive. Life could exist without these gases, or at levels too low to detect. The absence of evidence is not evidence of absence. For now, Proxima b appears to lack a thick, life-supporting atmosphere, but the search continues. Proxima b is our first detailed look at a potentially habitable zone planet around a red dwarf. The environment is harsh, thin atmosphere, intense radiation, and tidal locking challenge the prospects for life. The habitable zone is not a guarantee of habitability. Star and planet history matter just as much. These findings will refine our models and help prioritize future targets. The technology that revealed Proxima b's secrets now opens the door to studying dozens of other nearby exoplanets. Each new world adds a piece to the puzzle of life's potential in the cosmos. Proxima b reminds us that even our closest neighbor is profoundly different from Earth. It highlights how rare and precious our own planet's conditions may be. The search for life is a search for a second data point, a true Earth twin. Proxima b may not be that twin, but it brings us closer to understanding what makes a world truly habitable. NASA's revelations have transformed Proxima b from a statistical blip into a real, rocky world. We now see a planet slightly larger than Earth, tidally locked, with a thin, likely CO2 atmosphere and no clear biosignatures. The environment is harsh, shaped by its volatile star. These discoveries mark a leap forward in exoplanet science, moving from detection to detailed characterization. Proxima b sets a benchmark for what we might find around other red dwarfs. The journey is just beginning. Each new observation will fill in more of the cosmic story. As our technology advances, what other worlds will we discover? How many are like Earth, and how many are like Proxima b? The universe is vast, and the search for another Earth continues, just beyond the edge of our current gaze.